Speak.
Yeah, hi guys. Are you able to hear me?
Yes, we can hear.
Is it audible?
Okay, let's start. Yeah. Okay, so in this workshop, okay, so what I'm going to cover, I'll just give the outline first. Okay, then you can get the idea. Yeah, if someone is not muted, I will kick it out. Okay. Everyone mute. If someone has to speak question, then unmute. Yeah, so what I'm going to cover today. Okay, so first I will be starting with the big data fundamental concept. Okay, so what is a big data all about, and what are the different characteristics of the big data? And then we will go to the Hadoop fundamentals. So in Hadoop fundamental, basically we will be covering the Hadoop architecture. Okay, and Hadoop architecture, I will cover HDFS and then MapReduce. And today I will cover the one more ingestion tools, right? Sqoop and Flume. So this is today's agenda. Just I write it down. Okay, so big data fundamental concept. Then Hadoop architecture. So in Hadoop architecture, I will cover HDFS command, HDFS architecture. And next component is in big data, that is in Hadoop, that is a MapReduce. Okay, so that is a processing component. So MapReduce, I will cover the word count program. Okay, and some additional features of the MapReduce are there, right? Partitioner and combiner. So I will show the demo of that partitioner and combiner. Okay, so all these things I will be going to the install one by one. Okay, so I will show like how to install Hadoop, how to install Sqoop, and how to install Flume. Okay, and after that I will be covering the Sqoop is an ingestion tool. Okay, so to bring the data from the RDBMS database to Hadoop file system. So Sqoop is an ingestion tool. And the next one is Flume. Flume is also ingestion tool, but Flume is for the unstructured data. So first we need to understand all the big data fundamental concept, and what is the structured data, what is the unstructured data. Okay, so I will cover all those things. Okay, so I will start from my PPT. Okay, if anyone has any question, someone can ask in the middle. Okay, yeah. So what is big data? Okay, so what is the term big data? So I will explain this big data. What is a big data? Okay, so we are hearing this buzzword, right? Big data is around in our all the industries are using the big data. Okay, so when I say the data is a very huge amount of data, and we cannot handle with the traditional tool, right? We use the big data tool, right? Big data is a framework, and there is Hadoop is the implementation tool of the big data. There are many other tools of the big data implementation. Okay, Netezza is there. So, but these are not that much flexible or open source. So these are the constraint with those tools. Okay, so why we are going for the Hadoop? Okay, and what are the advantages of using the Hadoop? So I will show all this in the my PPT. Okay. So first, initially, when we start with the big data, right? So we see all the industries are using nowadays big data. Okay, either it is a manufacturing, banking, consumer. So everyone has the analytics. So big data, what we are doing exactly? So big data, we are doing the analytics. We are ingesting the data, which is very huge amount of data, and we are ingesting data in Hadoop file system that is on the top of the Windows or Linux file system, and then we are doing the analytics on top of the data. And once the analytics is done, then we are doing the reporting. So we know there are so many visualizations tools are there, Tableau, Power BI. So we do the visualization, right? So these are the main industries. They are using the big data. Okay. So Hadoop is one of the implementation framework of big data, basically. Okay. So in the traditional system, if you know how we do the processing things, like we have to think something and then we have to implement in a traditional way, right? So if I say in traditional way, right, if I want to solve any problem, right, so I have to make it small data, and then I can do the analytics on those small data, then I can combine my result, right? But in Hadoop, it's giving the huge amount of data we can process in a big cluster. Okay, so here is the horizontal. Please mute. So Hadoop Big Data is giving like a huge amount of data we can scale out or scale in on the big cluster, right? A set of node, right? So there is a horizontal scalability. I will talk about what is a horizontal and what is a vertical scalability. Okay, so these were the challenges in the initial traditional decision-making solutions. Okay, so when we come to the big data, so first thing is like we are getting a very large storage, right? Like we can process the data on a very large storage store, and there we can perform our analytics. And once our result is done, right, then we can go for any visualization tool and do the reporting. Okay, so now if we look at like what we need to learn in Hadoop Big Data. Okay, so if I say I want to do okay, how many things I want to do first? Okay, suppose I say I want to do analytics. Okay, so first of all, I need an ingestion of the data. So first ingestion layer will be there. I will read the data, or I will ingest the data from the different sources. Okay, because Hadoop file system, I cannot produce a large amount of data. Okay, for small data, I can prepare manually, but for the large data, I cannot prepare manually. I need to do the ingestion of the data from the different sources, and what these sources could be. So like file system is the one source, right? Okay, so there are the different types of files are there: CSV file, JSON file, XML file. Okay, Avro file. So these are some different file formats are supported by Hadoop. Okay, and the other sources are like SQL databases are there, RDBMS databases. I can say the example of RDBMS databases like MySQL, Oracle, SQL Server. So these are the, and NoSQL databases are there. Some NoSQL databases examples are Mongo, Cassandra, HBase. Okay, so these are the NoSQL databases. Okay, and some REST API sources could be there. So those are the streaming data sources. I will tell about the batch sources, the data which is coming from the batch form or streaming form. So two types of data ingestions are there. So here ingestion layer, we are ingesting the data. Once the data is ingested, then we are doing analytics. That is called analytics layer. So analytics layer, what we do exactly? We perform some transformations. So we will learn like so many transformations are there. Map, flat map, some Spark transformations, some basic transformations are there, filtering the data, joining the data, union of the data, right? So we are doing different transformations on the analytics layer, transformations. And finally, we are writing data to some data targets. Data target store. Okay, so those target store, again the same thing. It could be a file system, it could be a SQL, it could be a new SQL database, or it could be a REST service, or anywhere I can write the data. Okay, so here this is the ETLs, right? So we are working on the ETL, right? Extract, transform, load. So we are reading the data from the source and perform analytics, and then writing the data to the target. So this is the ETL we are doing. So some ETL tools are there, like Talent, Informatica. These are the ready-made tool. So there is a drag and drop features is there, right? So we have Informatica, Talent. These are the ready-made tool. But Spark is providing like custom ETL tool, right? It's like we are writing our own custom code. So here is a more chances, like you can do more customizations. Okay, so Spark is a one analytics frameworks. Okay, if I talk about what are the frameworks are there in Hadoop for the analytics. So Hadoop is provided, MapReduce is a one analytics framework, another one Hive is there, and Pig is there. So pig is completely obsolete, right? Nowadays, nobody using a pig. Pig is also ETL tool, okay? And here we have to write a code in the pig Latin script, okay? So now the two are there, MapReduce. MapReduce also people are not using because we have to write huge amount of Java code, right? So suppose one word count program I have to write, in the MapReduce, I have to write a 200 lines of code, okay? And Hive, I have to write only 1 line of code, and the pig, I have to write 4 to 5 lines of code. So if I say the productivity is not good in the MapReduce and the pig is fine, but nobody is using the pig nowadays, okay? So once our analytics frameworks we are using in Hadoop, but Spark is an extension of MapReduce because it is providing the in-memory computation, like we can process the data in memory, and that is 100 times faster in memory. That is 100 times faster in memory and the 10 times faster on the disk. So that is the reason nowadays people are using the Spark. So Spark is provided the various flavors are there. PySpark is there, Spark Scala is there, Spark Java is there, Spark R is there, Spark SQL. So there are many different flavors are there. But MapReduce we are using either we can use Java or Python. So we can use either two of the programming language, Java or Python. Okay. So, but we have to write use lines of code, right? So instead of that, like we can write either in Hive, we can write a SQL query, or we can use Spark to write in any programming language, Python, Scala, Java, we can write a code, okay, for the this ingestion and analytics and writing the data to the target, okay? So when we talk about what comes in the Hadoop ecosystem, right? So there are the different layers are there. So if we look at security layer is there, data storage layer is there. Okay, so if I'm talking about the cloud, so cloud is providing its own storage. So in AWS, S3 is there, GFS is there in the Google file system. Okay, blob storage is there in the containers are there, container storage is there in the Azure. Okay, so these are providing their own storage layer. But Hadoop is having its own storage layer is HDFS. Okay, HDFS is the on top of the Windows or Linux, like we install Hadoop, and then we will get a one Hadoop file system. And Hadoop file system is a virtual file system. We cannot enter in Hadoop file system. We can give the complete path to see the files and directory, whatever we store, we can see. Okay. On top of that, data processing layer. So either it's a batch processing or real-time processing or hybrid processing. Hybrid processing is the combination of batch and real-time, okay? And the query layer, analytics engine. So this is like analytics pipeline layer, okay? So when we come to the big data, so big data, like Facebook is using, these are the facts about the different social medias, how much data they are using per day, right? So this much of data volume they are using, so they really need the big data. So big data is providing basically, if I say Hadoop is providing a cluster node of set of nodes, and this set of node is the big cluster. So we can process as much as data is possible, like is possible, then we can process the data. So first of all, what are the these different types of data are there? So if I say this whole world is divided into this category, okay? So mostly the three categories, like if I say structured, semi-structured and unstructured. Structured data is data has a fixed dimension. So data has fixed dimension means like I can easily measure the data. If I say somebody's name is there, date is there, age is there, I can easily measure the data, right? Or some traditional tool, right? SQL databases, it's a form of the data is structured data, okay? Another data is unstructured data, that is completely like we cannot measure the data with the traditional tool. We need some specific APIs, like processing APIs are there, image processing APIs, video processing API. It could be in any programming language, but we need some processing APIs, okay? So like PDF, text document, images, audio, video, these are the unstructured data. And semi-structured data is a combination of structured and unstructured, okay? So semi-structured, I can say email. Email has attachment and subject is the body, subject, body are the text, okay? So this is example of semi-structured data, or CSV, XML, JSON. All file system data is semi-structured data. And another quasi-structure, this is like a special type, like click streaming data. So one example of the click streaming data is like I have some website, and this website, whatever clicks you are doing on the website, it is all clicks. It is capturing and then generating the data. So that data is called click streaming data. So this is a real-time data, and this real-time data is we generally use Kafka or some message broker tool. Okay, so this kind of tools we have to use for processing this click streaming data. Okay, so this is the data growth. I'm not going much on these slides because these are the more theoretical slides. So volume is when the data size is really very, very big, right? So I can say that that is the big data, right? So what are the characteristics of the big data? These are the 4 V's. So variety is when the data is coming from the different sources, like just like audio, video, images. Okay, so this kind of varieties of data is there. Velocity and volume, this is a proportional, because when the velocity will be there, the volume will be high. Okay, so velocity and volume both are the proportional to each other. And veracity is the truthness of the data. The data should be correct. So if data is not correct, if data is having the null values or missing values, or data is corrupted data, so I cannot do the data analytics. So for data analytics, the validation of the data is very important phase when we are getting the data from the different sources. So we have to do first validation after ingesting data. And whatever data is not correct, we will be discarded data and we will remove that data, right? And the corrected data, we will doing the analytics. Okay. So these are the category of the data. Okay. This is Royal Bank Scotland case study. Okay. Okay, so far it's clear. Anyone has the background of the big data, like why the big data came in picture? Because when I talk about the RDMS databases, so RDMS databases are the SQL databases. They have the vertical scalability. Okay, so first we understand what is vertical and what is a horizontal scalability. So vertical scalability has a limitation. Your RAM and processing, like CPUs, like you can extend up to some certain limit. Suppose I have a one machine, okay, and which has 64 GB RAM max limit. Okay, so I cannot go beyond that 64 GB RAM. I cannot go because its capacity is only for 64 GB RAM, or I say CPUs are it's a 10 core CPUs, okay, 10 core CPUs or 16 core CPUs. So I cannot go more than that because the capacity of the machine is limited. Okay, so that is called vertical scalability. And when I talk horizontal scalability, so vertical scalability is mostly in the RDMS databases. So one RDMS database installed on one machine, it cannot share the data across the machines. Okay, so that's a limitation in the RDMS. So that is the reason no SQL databases came in the picture, because they are providing the horizontal scalability. Okay, so RDMS databases, these are the vertical scalable. Okay, only same machine you can scale it or scale down. Okay, horizontal scalability, it is like set of node of cluster. Okay, and you can add as many as node. You can add as many as node in the cluster. Okay, we can add. So horizontal scalability is basically multiplying your capacity of the RAM and disk, right? So that will be providing the huge cluster, and there we can process the data easily, right? So when the data size is growing and the data is coming of the different data types, and these are the big hurdles, right? If I say I want to save some like a image, audio, video in the RDMS database. So I need to write some blob related code, right? Blob and clove. Okay. So blob and clove are in the SQL database, right? So I need to use these data types, and I need to write the extra code, right, to store the data or read the data. But when I'm talking about like NoSQL databases, I can dump the data, right? So these are the main advantage of using the like Hadoop kind of framework, and I can say the NoSQL databases I have to use. Okay. So these are the different use cases. Okay, I'm not going much on this. Okay, scalability. So I already talked about the vertical scalability and horizontal scalability. So Hadoop and NoSQL databases comes in the horizontal scalability. So here Hadoop and NoSQL databases. All NoSQL databases comes in the horizontal scalability. Okay, so Mongo, Cassandra, HBase, DB. So there are so many n number of lines are there. So these tools we can use the horizontal scale. Fault tolerance. What is a fault tolerance? It's very important, right? My data should be highly available, right? So if my site is down and data is not highly available, so that there is no fault tolerance. So fault tolerance means I should be highly, my data should be highly available. So when I say the cluster, so in this Hadoop cluster, there is a concept of master or slave node, master and slave node. Okay, I will go on the Hadoop cluster, like architecture, Hadoop architecture. There I will talk about like master slave architecture, and this master is highly available. If it is down, so another master will be there, like name node. Okay, I will talk about that. So master is here name node and slave is here data node. Okay, so fault tolerance is when master name node is down, so another name node will be there, or secondary name node will be there. Okay, so I should, and if data node is down, I suppose in my slave, if I'm going to access, so in that case, it should provide the replication of the data. So fault tolerance, two possibilities are there, right? Okay, I say either my master can down or my data node can down. Master means name node. Okay, so master means name node can down. So in this scenario, I have the two options. Either I can use secondary name node and standby name node. Standby name node. Okay, so that is a passive name node, but it will become active when the active name node down. Okay, and another one is data node. Okay, when the data node is down. So in this case, Hadoop framework is allocating another data node for the same data, allocating another data node for same block of copy. Okay, so that is called replication fact replication. Okay, so replication, like we can set up to 1, 2, 3, as many as number of replication factor we can set, so it will keep it copy of the data. Okay, so storage is not a problem, right? Main is if the user who is accessing the data, if he is not getting on the time, right, so it will be more concern rather than the storage. Like if I'm keeping the data on multiple machine, so storage is not a problem. Okay, so fault tolerance, data inconsistency. So once the data is like captured, like consistently, all the data should be sync also. So whenever any data change is happening. Okay, so this is all happening in the distributed system, right? So what is a distributed system? Like when the all nodes are connected to each other in a network, and it is creating a cluster, and one master node is having a observation of all the data nodes, right? So it is like there is a heartbeat mechanism is there between the master and the data node slaves. So every 10th of second, master node is sending the signal to all data nodes. If any data node is down, so that master node will assign the another data node to the client. Okay, so that is the mechanism is there in the Hadoop framework. So if I say the data is distributed, right, and the processing speed will be faster when the parallel processing will be there. So I will show you, right, some MapReduce program when you write. So it is distributed across the machines, and when your data is across the machine, it is distributed and parallel processing is happening. So your processing will be faster. So that is the reason Hadoop framework is having a processing speed faster. The reason is like it is distributed and parallel processing is there. So in the MapReduce, like map and reduce, two functions are there. So mapper is running parallelly across the machines, and the data is shared across the machine. Okay, so the processing speed will be faster, and the block size. Another reason of Hadoop has the block size 64 to 128 MB. So Hadoop 1.x, the older version of Hadoop 1.x has 64 MB. Okay. And the Hadoop 2.x and 3.x, the default block size is 128 MB. And it is also configurable. You can increase or decrease. Okay. So 3.x is a newer version. So there is a block size of 128. So what is the reason behind that? Why they kept it this much of block size? Okay. If we compare this block size with Windows or Unix. So Windows and Unix.
Hi, Arvind, Asta this side. Actually, I have one question. Yeah, so what is the difference between this distributed computing and this Hadoop? Like, what is the basic difference? Why we come to Hadoop?
No, distributed. Say Hadoop is having a distributed only. Distributed processing is just concept. Okay. So Hadoop is an implementation framework that is providing the scalability, high availability, reliability. So these are the features, right? So distributed computing is like a concept. Okay. Like when your data is distributed across the machine and these machines are connected to each other, they can talk to each other. Okay, so this
sure,
Hadoop is providing the name node, data node concept, right? This HDFS concept, Hadoop distributed file system, that is giving a communication. Okay.
Yeah, thanks, Arvind.
Okay, so who is invented Hadoop? Okay, so this is the background of Hadoop, the guy dog cutting. So this Hadoop, the picture is like he saw his son playing with the Hadoop toy elephant, small toy elephant. So he gave the icon for the Hadoop is elephant. Okay, so this guy started initially the two paper was published in the Google, like Google published two papers. Okay, one is a Google file system and another one is Google MapReduce. Okay, in 2000, Google MapReduce and Google GFS file system. Okay, these two papers published in 2000, but Google has not paid more attention on this. This guy 2004 started working on these two papers and he has given the concept of Hadoop distributed file system. So Hadoop distributed file system, he has provided a storage component. Okay, and this storage component is having a large block size. So what is the reason I was telling you why they kept it block size? So here I was speaking about they kept it block size as compared to Windows and Unix, that is only 6 KB block size. So if you see, like if you are opening any file, notepad file of okay 10-15 MB, so it will hang, right? Because the block size is too small. So it will create, because data is like, we are thinking the data is in MBs, GBs, TBs, but internally this all data is stored in the form of blocks. And this block is some particular size of the block is there. Okay. So if I say 6 KB block, and if suppose 1 GB file, how many number of millions of blocks will be there? And how much time it will read the block by block to read the data? It will be too slow, right? And that is the reason if I say like Hadoop 1.x 64 MB and 128 MB, it hardly 8 or 10 blocks. So data retrieval from the file system is faster. Okay, it's the same file system as like a Windows or Unix, but the top of that they have given the block size is more, so data can be retrieval faster and it is giving more processing speed, right? Because if we are not able to read data faster, we cannot process the data, right? So first of all, we need to read the data, right? If I'm loading the data in memory, so Spark is basically having a two concept, like one is reading data faster, second one is it is processing the data in memory faster. And memory, that is the reason any Spark program, if you need to run, you have a very high configuration of memory. If your memory configuration is not high, you cannot process the data in Spark efficiently. Okay. Okay. But Hadoop is doing, MapReduce is doing only batch processing. It is not having the real time. Okay. So real time processing and batch processing both are there in the Spark. Okay. So when I was saying here this 2004, this guy dog cutting has started work on this GFS, and then he has given another file system named Hadoop file system for the storage. Okay, so initial version of Hadoop came 0.x and 1.x version. So they have introduced Hadoop 2.x and now is a Hadoop 3.3.5. So the latest Hadoop version is going on, that is a 3.x version. So they have done a lot of modification in the Hadoop 1.x to 2.x and 2.x to 3.x, but 2.x and 1.x is the major release change, 1.x to 2.x, because 1.x they had the block size in 1.x, the block size 64 MB, okay, 64 MB, that they converted into 128, the default block size in 2.x. So 2.x and 3.x, the default block size, 0.x and 3.x block size is 128 MB. Okay. So that was a major change. Okay. Another one is MapReduce, the like from Google MapReduce paper, right? He introduced the MapReduce for computing. So when we are having some framework, like we need two things. Okay, some framework we need two things. One is storage and second one is a computing. Okay, if this storage and computing, these two are in a one framework, like we can easily process the data and store the data. Okay, so other big data frameworks are there, Netezza or this one, but they have the limitation, like they have individual components are there, like storage is separate and computing is separate, but Hadoop is having MapReduce and HDFS, right? So two component, like these are the two core component of the Hadoop, right? One is a storage for the HDFS and computing is a MapReduce. Okay, and further HDFS is having, this is a MapReduce. Okay, and the HDFS has further storage, like it's having name node and data node. Okay. I will talk about name node, data node, and what is the command of the HDFS. All I will talk about. Okay, so what are the characteristics of the Hadoop? Hadoop is scalable, like I already talked about that. It's having a horizontal scalability. It is flexible. It can process any kind of data, whether the data is a structured data, semi-structured, unstructured data, it can process. The reliability is there, like it is highly available, right? It is the data is in the different machines, so fault tolerance is there. If any failure happen, so it is providing the backup. Okay, and it is economical because it's an open source. There is no cost. You can create a huge cluster without any cost. But if you are going some distribution, so there are some companies, they are providing the distribution because they are providing the support. So companies are going for those distributions, right? Like one is a Cloudera. If you heard the name of Cloudera, and this guy Doc Cutting is now a CEO of this Cloudera, like he's the part of the Cloudera. So Cloudera is a one, Hortonworks is Cloudera, both are merged now. Another one is a MapR there. MapR is another distribution is there. IBM is having its own distribution. Okay, and Microsoft has its own distribution. Okay, and they are the different companies, they are on providing on distribution, but they are all using Hadoop and they are providing its own version of distribution. So either companies, why they are going for this distributed version, because they are providing the support. Okay, so what we are going to learn, that is our own installation, right? So this distribution, anyway you will get it in the companies, because you know, right, when you join any company you will be working on that environment, but you will not be able to learn how these things are installed fundamentally, right? So we need to learn also, right? Suppose if I want to create my own cluster, so how can I make it a single node cluster? By installing Hadoop, Hive, Sqoop, HBase, Spark, Kafka, Python, everything I can install on my same machine, a local machine, and that machine I can do, I can run. Okay, so when I want to go for cloud, then I can switch to a cloud, AWS, EMR, or their distribute Spark, Hadoop distribution. Okay, but when I want to learn, I can learn locally by installing all this component in my local machine. Okay, but these are the Cloudera, MapR. These are providing the ready-made cluster. And here everything is a pre-installed. You don't need to install anything. You can directly start, you download the Cloudera version, like from the Cloudera website, and then you can start the practice. Like you can use any Hadoop ecosystem component, you can use there. Okay. Okay, so another way is like we are installing we have Windows machine, and on Windows machine, on top of the Windows machine, we are installing Ubuntu using the VirtualBox. VirtualBox is a hypervisor. Okay, And once this Ubuntu is installed, then we will install manually all Hadoop ecosystem component. So we'll start from the Hadoop, then we have to go for Sqoop, Hive, okay, Hive, Plume, HBase, Uji. These are the so many different Hadoop ecosystem components are there, around 6-7 components. And then we have a Spark we can do, and we can install Mongo, Cassandra, HBase. Okay, HBase already there. Cassandra, Elasticsearch. So everything can be installed. Okay. So this is the way like we can do practice and we can start. Okay. So if I compare with the what is the difference between the RDMS and the Hadoop, right? So the very okay. So when I say RDMS and Hadoop both are uncomparable thing. Okay, because RDMS is okay. RDMS is a SQL database and Hadoop is a platform. Hadoop is not a one tool. Hadoop is a set of tools are there. Okay. Okay. So Hadoop is having the set of tool. So when I say what is the difference between the RDMS, so RDMS is one like a structured data it's supporting, but Hadoop is multi-structured, like it's a semi-structured, unstructured, and semi-structured, unstructured, all type of data it is supporting. And here is only structured data, and the schema is here on the right, like basically when you are writing the data or when you are writing the data in the SQL database, the schema is validated. But in case of Hadoop, right, if I'm using Hive, so in Hive, when I'm writing the data, it will not validate your schema. It will quickly write the data into the table. But when you are doing the select query, then it will check your schema. Okay. So here the processing thing is faster in Hadoop. Okay. So here reads are faster, here writes are faster. Okay. Because when you are doing the SQL query, it's using indexing, right? So indexing is faster, right? Like basically it's reading the randomly the data, right? So that read is faster in the SQL database because we are writing SQL query. But Hadoop is a hierarchical file system. It's a tree-based file system. So when it is searching the data on your file system, so it will be going a sequential manner. So definitely read will be slow, but writes are faster. Okay. So and this is for OLTP, online transaction processing, right? Like when we are doing any transaction kind of data we want to store, we can write in the RDMS databases like SQL databases. But here we are using analytical purpose, right? The historical data I have 10 years, 15 years, 20 years historical data. And that data analytics I want to do, I will go for so then we go for Hadoop. Okay. So Hadoop is having the various tools. So what are the Hadoop core component? Okay. So Hadoop core component, Hadoop HDFS is a storage component. Okay. And MapReduce is a processing component. Okay. There are other processing component like Spark is there on extension of the MapReduce. Okay. So it is all managed by the Yarn. So Hadoop 2.x has given the Yarn concept. Yarn, another resource negotiator. Okay. So Yarn, another resource negotiator, has the Hadoop 2.x architecture. I will show that the architecture. Okay. So here, if we talk about the data ingestion tools are there. So Hadoop ecosystem is divided into the set of tools. Okay. So ingestion tools, these are the separate tools are there. Analytics tools, those are separate tool. Scheduler is a separate tool is there. Uji is a scheduler tool. Okay. Ingestion tool is a Sqoop and Flume. So Flume is for unstructured and semi-structured data. And Sqoop is a structured data, like data is coming from the RDBMS database. I will use the Sqoop. Flume is for unstructured and semi-structured data, like data is coming from the streaming sources, like Twitter, the data is coming from Twitter, Kafka. So this kind of data is coming, the streaming data. So we are using the Flume. Okay. And storage layer. So once the data is ingested, like right now we are using the local machine. So we are having a Hadoop file system. And once the data is ingested in Hadoop file system, then we are processing by the either Hive we can use, or MapReduce we can use, or Spark we can use, or data analytics tool we can use. And then we do the visualization. Okay, so we can do the data visualization in the Tableau. Okay, so Cloudera is having its own set of tools are there. So I already discussed, like Cloudera is having Hue. It's having a set of same tools are there, but they are providing the user interface. So Hadoop user interface. So you can like query the data to the Hive, everything you can do there. Okay. Okay. Okay, first, anyone question? Hello. Okay, so I'm just showing the first installation thing. Okay, so let's start the installation. So everyone has the virtual machine, okay, or you can set up your virtual machine by installing the Ubuntu on the Windows machine, and then VirtualBox, and then you can install the Ubuntu. Okay. Okay, so this is my new machine. I have not installed yet my Hadoop on this machine. Okay, so I'm going to install the Hadoop. So when you start your virtual machine, right? When you start the virtual machine, so some of the things you can do on the virtual machine. Okay, so when you want to install, like you want to install the Chrome, so this is the steps for the Chrome. Just you download the wget command to the Chrome installation, and then you can run this command. It will install your Chrome. Okay, and if you want to enable the bidirectional copy paste, so you can go to the virtual box here, and here you can go to setting, and here in the advanced you can set the bidirectional. So shared clipboard and drag and drop. So these are the small things you can do, like how can you use the virtual box. Okay. Okay, so once you come to the, like, okay, so I have created a one directory, okay, in my home folder. So everyone is aware with the Ubuntu. So here in the home folder, so this is my home folder. Here I created software directory. In this software directory, I will copy whatever the softwares I'm downloading, right? In Hadoop ecosystem softwares, I will be downloading here, and I will copy paste here. Okay, and then I will use it. Okay, so I have created the software folder. So you can create in your username, because this is my username. If you see my terminal, so in my terminal, it is my username. This is my username. Okay, so when you install Ubuntu, you have to set your username, and you have to set the password. So once you log in with your username, and then you can like go to your user folder, and then there you can create a software folder. Okay, so first I have to do sudo apt update command. Okay, so I did sudo apt update. So it is asking my root password. Okay, and one more thing is, who is installing this Ubuntu 22.03 version. So initially they will be getting some error like sudo is not in a file, right? So they will not be allowed any operation. They can't do any one of the things. Okay, so first of all, they have to come to sudo su minus and give the root password. What is the password of the, and after that they have to do vi sudo. When they do vi sudo, they have to add their user. Everyone has to add their own user. Here one entry they have to do. If they do this entry, then only they can perform any operation, because this Ubuntu 22.04 newer version, they have given a one like a restriction, or you have to first enable your user in this sudo file. You have to add. Okay, and then you want to save it, Control X, Shift Y, and enter, because mine is already changed. That is the reason it is not giving any confirmation. Okay, so when I do vi sudo, then you can do Control X, Shift Y, and enter. Okay, so you can do that. Okay, So I just write it here. You have to do first su minus, then you have to do in the root folder, you have to do vi sudo, and then you have to add your entry. I just copy paste the same entry. For this entry, you have to give your entry, not my entry. You have to give your entry. After that, you do Control X, Shift Y for the saving the file, and then plus. Okay. Once you do this, then you are able to run any command. Okay. Okay. So I have already installed JDK. Okay. I'm not going to install this. Okay. So next thing is I have to install the OpenSSH server and client. Okay. This is for the password, serverless password authentication purpose. We are installing the SSH. Okay. So for Hadoop services, like we have to, when we are going to install Hadoop, I have to install this OpenSSH server and client. I'm going to install. It is very, very straightforward. If you are following the steps correctly, within 5 minutes, your Hadoop will be installed. And if you done something wrong, so you cannot find your error even the 2 hours or 5 hours. Okay. So this installation is completely like step by step, right? So you have to follow the steps correctly, and then your Hadoop will be installed within 5 minutes. Okay, this is for keygen, like local private key, public key I'm creating. This is I'm adding this my public key to the authorized key. Okay, same steps you can see here, the link I provided. This all links I copied from here. Okay, so you can follow from this website also. And then you can give the ch mode 600. You can give the permission. Okay, this is permission we are giving. And then we will test it this local host. This is just for checking purpose. So my local host is connected or not. I will say yes. So my local host will be showing connect. Okay. So after this, the next thing is I need to download the Hadoop zip, because Hadoop is not binary. It's a binary software. Like I need to download from the website. Okay. So I will go to this browser link, and I will download this tar file. I have mentioned it everything. Download the tar file and extract this Hadoop 3.3.5 version. And then you can copy to the software folder and copy in the home Arvind softwares folder, you copy. It's maybe around 350 MB. So it will take a little bit time. Yeah, passwordless is. Oh, it is already installed. So it will be download in the download folder. So I have to go there and extract it, and then I have to copy paste to the my software folder. Okay, meanwhile it is downloading. We'll see this. Okay. So I will be covering today SDFS, MapReduce, and Sqoop and Flume. So these are the 4 components. So I will do the installation of these, and then I can show the demo. So okay, what is SDFS? So I already described about the SDFS. SDFS is the Hadoop distributed file system. So it is providing the cost, speed, reliability need for the SDFS. Okay. So how it is different from the regular file system? Because the block size is very small in the regular file system, but Hadoop file system has a larger block size. So that is the processing speed is faster. Okay. So the size of the data is very, very small block of the data. Here is a 128 MB large block. So number of blocks will be lesser as compared to here. Okay. So SDFS storage. So what I was talking about, the SDFS has the name node. So name node is containing only metadata. So metadata is nothing but data about data. So I have a different data nodes are there, and all these data node information is stored in the form of metadata in name node. Okay. And data node is containing the actual data. Okay. So when I say all the data nodes, actual data is stored in the data node, and the metadata is stored in the name node. Okay. So for the high availability, right? So there is a 2 files are there. One is, anybody is asking question? Okay, so what is high availability architecture is there? So basically there is in Hadoop 2.x and 3.x, they have given the one active name node and one standby name node. This active passive name node, this standby name node will be passive name node, and it will be active. It will be active when the active name node is down. Okay. So earlier in Hadoop 1.x architecture, that there is a secondary name node concept. So secondary name node takes 30-minute time to start, and it is taking 30-minute delay to sync the data, metadata from the name node. Okay, but in the Hadoop 2.x and 3.x, they have given this standby name node. This is every minute it is syncing the data. So there is a journal node is there that is in between the active name node and the passive name node, and that is syncing the data between these two. And the Hadoop file system is using, one is FS image and another one is a edit log. So there the 2 files are there. So when I say okay, so this FS image is the Hadoop file system copy. This is the memory copy. Okay, FS image is a memory copy of name node data, name node metadata, name node metadata. When I say my name node is down, okay, so again when the name node starts, right? So it will populate from the FS image. Okay. One file is a edit log file. Edit log file is a disk copy. Edit log file is a disk copy. So edit log file is a disk copy of the metadata. Okay, disk copy. Okay. So when the name node machine down and it is starting again, it is reading from the edit log and create again FS image copy. Okay. So these are the two files maintained, right, by the Hadoop file system. One is a memory copy and one is a disk copy. So whenever disk copy will be permanent, but memory copy will not be permanent, right? Because whenever name node down, it will start again and it will take the backup copy from the edit log and create a new FS image. Okay. So all metadata is always stored in the FS image copy, right? Memory copy. So whenever you are doing any request to the name node, so generally what happens, like when we are doing a read and write operation, so read and write operation in the HDFS. Okay. So as a client or user, I'm sending a request to the name node. Okay. I want the particular file. So name node will identify for this particular file. Suppose I'm doing a read operation. For read operation, it will identify how many number of blocks are there and these blocks locations of the data nodes. Okay. And once it will identify it, and it will assign those data node directly to the client, and client will start reading the data. But some point of time, suppose one data node is down from the data is being read. Okay. In that case, name node is actively is giving a heartbeat signal to all data node. And whenever it find any data node is down, so it will assign another data node of the same block of copy. So that is basically high availability thing. Okay. So types of Hadoop file system architecture. So this architecture I was talking about, the quorum general node. So quorum general node is syncing the data between the active name node and passive name node. Okay, it is downloaded. So I go to my download folder. I will extract it. So this is a Hadoop 3.3.5 binary version. Okay. So there will be source also, but you need to download only binary. Okay, not the source. So this is a binary file.
What is the latest version of Hadoop, sir?
The latest is if you go to here, you can see this Apache Hadoop, this download. If you type Hadoop download, you can see the official website what is the latest release. Okay, so some beta version release are there, but you can find the stable release if you go to download Hadoop. So 3.3.5, the distribution folder. So we can see here the release, which release is current. So if you see time, you can see also 2023 March. Okay, this is the latest release. Okay, so you can see it. Okay, once this is extracted, this Hadoop 3.3.4.
Yeah, that FS image, when it is primary name node is active, that time it is taking backup of everything. When the second server is down, that time it is utilizing that
It is keep
FS image
thinking
for secondary.
Yeah. The FS image and edit log file concept is edit log is the disk copy and FS image is the memory copy. Okay, so it is always like keep updating the disk copy, right? Because if your name node is down, so we will lose the all metadata, right? So this edit log is always syncing with the FS image. Okay. So this FS image edit log is a common concept in the Hadoop 1.x, 2.x. This is the common concept. But Hadoop 2.x has given extra, that is a high availability through the passive name node. Because Hadoop 1.x has only secondary name node concept, and secondary name node is syncing metadata. Okay, this FS image edit log file will be there also. Okay, but this syncing, the backup node is there, right? Secondary name node. Okay, that will become active name node. Okay, once your name node is down in Hadoop 1.x, so that takes time. So that is the reason in Hadoop 2.x, it's they have improved it and they have given standby name node, which can active within a minute. Okay.
Okay.
Okay. So once
how would you upgrade the Hadoop if you've already installed the previous version?
previous version, you can find it, like you can find on Google, you can install, but you will not get the more documentation on that, and it will be having this issues, right? So what is the use of the previous version 1.x, 1.2.1? Okay, so either you go Hadoop 2.x or 3.x. Okay, so at least you can use the whatever the newer features in the Hadoop 2.x and 3.x, you can use it.
My question is, if you have a previous version, how do you upgrade to the latest version released?
The previous version, that is the admin side thing. Okay, Hadoop upgrade. Okay, so that is a version upgrade. Okay, so that is a completely admin part. Okay, so for development, we are just learning installation, but we are not going upgrade, right? Mostly they are doing a fresh installation, or if they have the Cloudera or some, they are using distributions, right? Or distributions is giving an upgrade. So they have the community support, they have the support, right? So they are upgrading, like even the minor version or major version. Okay, but when we are installing our Hadoop, like personally, then we can install a new version, right? Okay, we don't need to do upgrade. Okay, because this is a vanilla Hadoop, right? Okay, so this is not a distribution, so everything we need to manage, right? Installation or configuration management, everything. Okay,
So
here I'm just copying.
If I understand correctly, if you need the newer version, you reinstall again. Is that what you said?
Yeah.
Okay, thank you.
So first I'm copying to this software folder, this Hadoop 3.3.5. Okay, so this I copied in the software. So I'm keeping it all my software installation in this software folder, so I can easily identify. What is the question? Yeah, what is the question? Okay, so once I copied this Hadoop 3.3.5, okay, so next step is I need to set my Hadoop home path and the bin path. Okay, so I have already set this. So here one change you have to do when you're following this file, so you have to change your username. Okay, this is my username and this is coming. Okay, so when I copy this and I have to open the bash rc, so nano is the editor, bashrc, this is a bash file, and all the like home path we set it here, bash rc. Okay, so I will go at the end of the file. I will copy paste this, and I already changed it, so I don't need to change. But when you are doing, you have to change the correct folder path and your username. Okay, and then you come out from this file, Control X, Shift Y, enter. And one more thing you remember, right? After doing this change, you have to do source command. If you didn't do source command, your changes will not apply. So you have to do source command. Okay, and after that, I have to set the Java home path in my Hadoop env.sh file. So if you go here, copy this, export Java home, and now I go to the Hadoop etc folder, Hadoop, and here is my all configuration file. So first I'm doing the change in the Hadoop env.sh. So in this Hadoop env.sh, we can paste this Java home and save it. Okay, next change is I can close. Okay, next is I have to open the core site.xml. So core site.xml is also the same location, core site.xml. So I will copy this configuration. I go to my Hadoop file location. Here is a core site.xml is here. Core site.xml, open this file and replace on this configuration tag. Okay, And here already I change it. So you should remember it when you are doing the change for you. Then you should change to your username. Okay. Otherwise, your Hadoop will not work. So I
This
will
all
say
changes we can do in terminal also, right?
terminal
Arvind?
also, but I'm doing faster way here, right? Okay. So
Cool.
terminal
Thanks.
also you can do. You can directly go to this location, this file, you can add it, and then you can change. Either way you can do. Because here I'm doing quickly because I know these files are here, and then I can open the file and then do. So HDFS site.xml, this is all configuration file, and these files are as a services, right? Okay, and here also I did already change my username. I changed 2 places. Here one place data directory, and one is the DFS data directory as of a name node, and one DFS data directory for the data node. Okay, so this change I had done. So this is the one file. Another one is mapret site.xml. So mapret site.xml I will open, and here is the change. Here is this is the maplet site.xml. The one last is yarn site.xml. Yarn site.xml. This is Hadoop 2.x having the yarn site yarn. So here is the yarn site.xml. So this yarn site.xml configuration change. So here is we don't need to do our own change. Only core site.xml and HDFS site.xml you have to do your own change. Okay. And other files you can change. You can as it is copied. So yarn site.xml. So here I pasted. Okay, so now all things are done. Now I have to do HDFS name node format. HDFS is like a format command. You are formatting. Okay, so when I do HDFS name node format, so it will format my name node, and my Hadoop is ready. I can do command start -all.sh to start all the services. So start all.sh. So it will start thing, anything to operate on the HDFS. What is it? Let's see. My entry is not sure. Shift Y, enter, source, source, HDFS, or from. So I delete my earlier folder. This. Now this time is coming a different error. This is this name node, data node, and these are giving the permission denied error. Okay, we do this SSH of this one again.
Instead of start and stop, we can use restart command. Arvind,
Which one?
instead of this start, stop, all dot sh, can we use restart command?
No. This is for this services we are starting, right? There's no
Yep.
So either you use start -dfs for the name node, data node, and secondary name node, and start -yarn for the resource manager. But start all is for all. It is for all. Yeah, I think now it's fine. Okay, that SSH installation was not properly done. Now we are not getting any permission denied error. I told like if this installation properly steps are done in 5 minutes, otherwise it may take hours. Okay. Now we check JPS. All 5 services are coming. So name node, data node, and secondary name node, these are storage service, and resource manager and node manager, these two are the resource manager, node manager, these are the yarn service, okay, for the processing part. Okay, so how I can okay, so one UI also I can see. Okay, so if you want to check the UI, right, so there is the localhost, the browse file system you can do 98704. So you go to, after installation Hadoop, you can see the UI of Hadoop file system. So this is only for view purpose. Okay, you can see what are the files, directories in your file system. So you go to utility, and there is a browse file system, and here you can see the all listing of your files directly. Right now nothing is there. So when you click on go, you will not see anything because your Hadoop file system is an empty file system. There is no files directly. You didn't do anything so far. Okay, so it is empty file system. Okay, and if you want to see resource manager, that is for yarn, right? Like, okay, you want to see so there is a cluster manager is there, yarn resource cluster manager. So localhost 8088 port is there, localhost 8088. Okay, so when you run this, so you can see your jobs. Suppose you run some MapReduce job, or you run Hive, Sqoop, any job you run, you will see the status over here. So 2 things are there. This is for storage part, right? You can see your file system, and this resource manager is called cluster, right? Your Hadoop cluster, right? You can see all the information here. So how many jobs are running, how many jobs are finished, accepted mode, running mode. So all information will come. When I will run the MapReduce job, I will show you how to check on the UI and how to check through the command line. Okay. So now we are going to start first the Hadoop command practice. Okay. So Hadoop command, all are the starting with the Hadoop FS prefix, right? So we can create a directory, create a file, copy a file, everything we can do. Okay. So I told you Hadoop file system is a virtual file system. You cannot do any CD command. Unless you do, it is showing you the local file system, right? But when you want to go in local file system, you can go in any directory. You can use CD command, but here is no CD. You have to give complete path of your files or directory. Then you can see the content of your file. Or if you want to list your directory, you have to give a complete path of the root. Okay. So when you do Hadoop fs -ls/, so this is a slash is a root directory. So right now you will not see anything. This is a warning message. Okay. So you are seeing nothing, right? Because nothing I have created. So first I'm going to create a one directory, Hadoop fs mkdir. So mkdir is the same command which we use Linux. So difference is here, what is the Linux or what is the Hadoop command? So whatever Hadoop command you are using Hadoop fs prefix, Hadoop fs, then minus. And after that you are writing the Linux command, mkdir. So I want to create some directory test. Okay. So I'm creating a directory test. I want to check this directory is created or not. I will do Hadoop fs -ls. Okay. I want to create another nesting directory inside this directory. How to create Hadoop fs -mkdir. So I have to give the path of the root location, and then I will give the another directory like this. Okay. So I can see like here I want to see what is inside the test one. So I have to see the complete path I have to get like this. So right now nothing is there in the test one, so I am not able to see anything. Okay, but suppose I want to create 4 directories together, nesting directory. So one way is you go inside the directory and then create directory like this. You can give the root path, right? But if I want to create all together, we know in the Linux there is a -p option is there. So Hadoop FS minus mkdir -p, and then you can give the, okay, so this is a new root directory I'm creating. I say testing 1, testing 2, testing 3. Okay, now all 3 directories will be created in a one go. So if you see here Hadoop FS minus ls slash, okay, when you do Hadoop FS minus ls, so first label you will see test and testing 1. If you want to see the second label, so you will see testing 1, then you will see testing 2 also created. When you want to see testing 2, then you will see testing 3. So can you see here, you are able to create in a one go. But if I try without -p, what it will do? It will give you the error, directory not found. Okay, like suppose I'm changing here 3, 4, 5. Now you will get the error because the first this directory is not created, right? So testing 3, testing 4 is not there, so it is not able to create your directory. So -p option you have to use. Okay, the next command is how to copy the file from the local file system to Hadoop file system. So there is a 2 commands are there. One is a put command and one is copy from local command. Okay, so first I create a one file here, cat my data.txt. So this is a way to write a file right in the Linux. So Linux command you should improve, you should learn. So Control D, and here you will see my file is created, my data.txt. I want to write this file in Hadoop file system, so I will use put command and I say my data.txt and I give my directory. So I created a testing 1. I created. I want to copy in this directory. It will copy. Okay, I want to copy in the testing 1, testing 2. It will copy. It is not giving any error. If I do this command again, what it will do? It will give me the error because it's saying file is already exists, but still I want to update this file. I want to overwrite my file. So there is the option -f. So -f is a forcefully you want to write the data into your Hadoop file system. You can give -f and then you can override it. Now it is overwritten. Okay. So I want to see the content of the file in my Hadoop file system. So Hadoop fs -cat. So generally we use a cat command to see the content in the Unix file system. So here I will be doing testing 1 / my data.txt. So this will show the content. Now if I go to the my file system here, okay, so I have created these many directories and files. Okay, so all has come here. Okay, all have come here. So if you go here, test and testing 1, if I go test 1, so here I have not copied any file. Okay, I want to go back to directory and then testing 1. So here I copied one file. So you can see here you can download the file also from your Hadoop file system. So you can download. The file is downloaded. Okay. So this is a way like how to work with the Hadoop file system. I'm telling you more command. So this is how to see the content of the file. Okay. Now another command is there, copy from local. Hadoop fs minus copy from local -f my data.txt. Same command I'm running, but this time I'm running not put. I'm using the copy from the local. So both are correct. Testing 2. Okay, so I'm overriding the file by using copy from local. Okay, I want to get the file from Hadoop file system to local file system. So command is Hadoop fs, and you can see all the command here. Just type Hadoop fs, so you will get the all listing of command. These are the all commands are there which you can use in Hadoop file system. These are the all command lists. Okay, so you can see append to file, cat, chgroup, checksum, chmod, chon, concat, copy from local. So all these command, whatever I am telling, all commands are here. Okay. So when I do Hadoop FS minus, I want to get the file in my local file system. So get command is there, Hadoop FS minus get, or copy to local. Okay, so get, and I will give the Hadoop path here. So my Hadoop path is a testing1/mydata.txt. Okay, if you use dot here, it will copy in the current directory. Or if you give your local file system path anywhere in your local file system path, you can give. If you give dot means in the current directory, it will come. Okay, so when I do here, my file is already there, this name, right? So again, the same error I'm getting, file like this. So what I need to use here, -f. But we have to very alert, right? Because we are going to update our local file. Okay, so just we make sure, or otherwise the other option is, if you don't want to use -f, you can give some different name. Okay, I gave my data1.txt. So it will copy. This is all Unix rule. Nothing is Hadoop here. Okay, so here I'm just copying the file with a different name. If I see here my data1.txt is, so it's the same content. If I do cat command, my data1.txt, so I will see the same content. Whatever I loaded in the Hadoop file system, same I have got. So either you can use get or you can use copy to local. Okay. Next command is, I want to, okay, Hadoop fs minus ls slash I do. Okay. I want to create I want to do the merging of the two file and create a new file in Hadoop file system. Okay. So suppose example of this my data and my data1, these two file I want to combine and then create a new file in Hadoop file system. The command is Hadoop fs minus append to file. So when you use append to file, you have to give the two file path. So you just simply say what are those files are there, my data.txt, my data1.txt. So these are the local path, right? So I don't need to, this is not a Hadoop path. So I have to give directly. Okay. And I will be giving where I want to create a new file. I want to create a new file, testing1/my data copy.txt. Okay. So
Is the command case sensitive? The append to file, is it case sensitive?
yeah, case sensitive.
Okay, thank you.
So you got the copy of these two files combined together. Okay, now we check the content of this file, Hadoop fs minus cat, then testing1/my data cp.txt. So I can see my content is coming 2 times, right? So it is combined the content and put it into the Hadoop file system. The reverse command of this command is get merge command. Suppose I have two files in my Hadoop file system and I want to combine the content and I want to get back into my local file system. Okay, the command is Hadoop fs minus get merge. Okay, and here you have to provide the two Hadoop file system path. Okay, so one is, I say testing1/my data cp.txt, and one more place I copied the file, like testing1/testing2/my data txt. And now these two Hadoop file path are given. Now I have to give the local file path. I can give the path, or I can give the some name. I can say my data cp.txt because this file is not there. Okay, now I do cat command because I copied in my local my data cp.txt. So can you see 3 times is coming? So already in my data cp.txt having 2 times, and testing1.testing2 this having a 1 time, so total 3 times I'm getting the content. So this is the reverse of append to file. Okay, if you see here, ls slash, okay, so here in the, I can see here, okay, no replication factor is coming. Okay, suppose the default replication factor is 1. Okay, and I want to set the replication factor for a particular file. Okay, so there is a set rep command is there. So Hadoop fs minus set rep. Okay, I say recursively I want to set testing 1. Okay, so something I missed it. Set rep command, you can see here all the options. So set rep is minus R W, and I can give the path. Set rep testing 1 slash my data.txt. Okay, I have to give the number. Actually, last time also I forgot the number. So what the replication factor I want to set, I have to tell my replication factor. So my particular file, the replication factor is 3 set. Okay, so I want to see this file Hadoop fs minus ls slash testing 1. Okay, testing 1 having this file, right? So I have to go to the testing 1 directory. So here you see this file is having 1, that is a default replication factor, but this file is the replication factor is changed 1, 2, 3. So this is a command line way you can change the replication factor. If you change in the replication factor in the HDFS site.xml, it will applicable to whole file system. So whenever you change and restart your Hadoop, and then next time you check, like you will find everywhere 3 will be there. But if I want to change for my specific file, I don't want to change the whole system, so I go for this command line. So set replication is a command line way to change a replication factor for a specific directory or a specific file we can change. Okay, so that is a way to change the replication factor. Okay. Okay, some other commands are there. Okay, if we do Hadoop fs, so some like permission things we can set it, right? Ch mode, ch on, and ch group. 3 commands are there. So these 3 commands are used for, suppose I want to change the permission, I want to change the group, I want to change the owner, and R for recursive. Okay, so I can use ch mode, and I want to, okay, first I see the permission. What is the permission there? Hadoop fs minus ls testing 1. So if I see, I know in the Linux, the permissions are the user label, group label, and others, right? Read, write, execute, read, write, execute, and read, write, execute. If I see this directory, this particular file, so this is user level permission, there is no execute permission, group label, write and execute is not there, and other label is also write and execute is not there. So I want to change the permission. So same command, Hadoop fs minus ch mode, 777 for all, read, write, execute for user, group, and others. And then I give this particular file. And even you can set the directory recursively, my data.txt. So it will change. So if I do this command again, I will change, it will be to read, write, execute. So this way you can use the permission. If you want to change the group, so ch group command is there. So ch group, so particular file like group you want to change, ch group. I change the group. So you can change the group. Okay, you can change the owner. So all the commands are there. Okay? So you can do practice of those commands. So Hadoop fs. One command is there, uses command. Like you want to see the use of your particular command. So you can use this command, Hadoop fs minus uses, and particular command you get ls. So I can find, this is an informative command. So there are the different types of commands are there. Some commands are an informative command, just providing you information. and some command are the manipulation command, like you are doing some manipulation. Okay, suppose I want to remove the files or directories, okay, in my file system. So we have an Unix rm command is there. Okay, so we can use the rm or rmdir command. So I want to remove testing one. So this file is deleted, but there is no confirmation because this file is gone. Okay, but I can because Hadoop file system is also managing one trash. Okay, so if you are maintaining on trash, okay, so you can recover your file or you can get the confirmation before deleting the file. Okay, so there is a different commands are there. So we need to configure our trash in our configuration file. Okay, there we need to define the time interval, and then it will go to the particular trash. Okay, and this trash you can recover the file. Okay, sometimes the file is deleted. So, and one command is the expunge command. Expunge command, like when you want to delete your trash. So if you do simply Hadoop API minus expunge, so it will delete your trash. Okay, so if this command is just doing in the background, it is doing that delete the file in the trash. So Hadoop API. Okay, so touch command, like you want to create a new file with the 0 size of file. So you can use the touch command. So touch and touch G command. So you can create a new file with a 0 size. Hadoop fs minus touch. Then you say slash testing one slash test.txt. You go Hadoop fs minus ls slash testing one directly you want to see. So here you will see the 10 size file is created, test.txt. Okay, so this file is created. One command is there, truncate command. So truncate command is like you want to remove the content of your file and it will directly apply your original file. Okay, so if you say Hadoop fs minus truncate, truncate. Suppose I say I want to get only 3 characters. Okay, I want to keep it only 3, and I just gave. Okay, there is a minus W option is there. Minus W is for waiting. Okay, so 3, and then you say the file testing one slash. Okay, test.txt doesn't have data. My data cp.txt. Okay, so now your length has become 3. So 3 means you are telling about how many characters you want to keep it. Okay, you want to keep it 3 characters, so you give 3. Now you see the content of the file, and you say testing one my data cp.txt. So only 3 characters are there. So this is your truncate command. Okay, stat command, tail command. Tail command very useful. Like whenever we are watching the log, right? Seeing the log. So this is tail command is mostly used in Unix also. So I have some file. Okay, and I'm going to open this file Hadoop fs minus tail, and I say my file my data p.txt. Okay, I have to give complete path. Testing one slash my data.cp.txt. So you will see your file is in hold, right? You cannot run any other command because this file is hold, right? So generally when you look at the log, right? So your logs can keep appending. Generally the tail command we use for that purpose. Okay. So I open a one terminal, I will add appending the log in this. Okay, I will add the data in this file. Okay. So I will use append to file option. Okay. So Hadoop fs minus append to file. and my local file system files, my data .txt, my data 1.txt, and I approve. Load the data, testing 1, data cp.txt. So I send some data here. Now I see your data is keep appending. Okay. So this is the use of the tail command. Okay. So when you are generating some logs in the Hadoop file system and you want to keep watching your log, so you will use the tail command. Okay. Add command is also there. Like you can see the starting of the file you can use. So if the file is small, the entire content will come. Otherwise, the 10 lines it will come. It.txt. Okay, so this is the head command. Other commands are there. Hadoop API. So these are the around 30-40 commands are there. Okay, so all these commands you can practice. Ch on, ch grow, copy to local. Count command will be giving you the any particular directories, how many files directories you have. This is informative command. Okay, so you can use Hadoop fs minus one stat command also there. So you can see the statics of your directory. So testing or file particular date and time it will tell. Txt. Okay, this is date and time is saying. Another one count command is there. The count is you can use for the directory. So it will tell how many files directories are there. So this is saying this is the total bytes of data. This is the directory. This is count of file directory. It is giving the list of those details. Okay. Any doubt, anyone so far this commands?
Arvind, every time when
Hmm.
we do any activities, we need to pass complete path, right? So
Yes,
without path,
yes.
we can't do anything.
No. Yeah, you seen that if I'm just typing the file name, it will be saying not found because you are
Yes.
searching in Hadoop. See, if you are giving only just mkdir, this is understanding this Linux command. When you are giving Hadoop FS and I'm saying minus cat, okay, and I'm saying my data.txt. So you are two opposite thing you are saying. Here you are saying this is Hadoop FS. I want to go for Hadoop, but you are giving a path of local. So
Yep.
either one thing you have to change. Either you remove this or just do cat, or you just change to this to Hadoop file system. So you have to give the complete path. Yeah. So this is a virtual directory. Yes.
Yeah. And apart from that, there is a same between
Hmm.
Linux commands and Hadoop commands.
Hmm.
I think similar, not
Yeah,
same,
commands
similar.
are same purpose. Everything is same. Right.
Yeah.
Okay. And one more command like, okay, we know right CP or MB command. Okay.
Yeah.
CPMB, what is the purpose, right? CPMB is like basically copying the file,
Copy.
same file system to like same file system. Here also CPMB is there. Here also CPMB there. But this CPMB here is Hadoop file to Hadoop file system. Okay. So far we have seen either we are reading or writing from the local to Hadoop or Hadoop to local using the put command or get command or copy from local or copy to local. But if I want to copy Hadoop to Hadoop, this can be also a scenario. Like I have a two directory. I say Hadoop FS minus CP, and but both paths should be Hadoop only. Testing 1, my data. What is a file here? Okay, I want to. Okay, testing dot my data or cp.txt. Okay, my data cp.txt. This file I want to copy to another directory testing 2. Testing 1 dot testing 2. Okay. So now this is Hadoop to Hadoop copy. So it is done. And if I am doing this command again, what will happen? This again minus f I have to use. Okay. So whenever this kind of scenario is there, or you change the file name. So that is a one option. Either you change file name or you just want to override it. then
Forcefully,
use
we can override that.
So this -f you can apply anywhere. Okay. This is a common attribute. So now it is copied. And if you want to do cut paste, right? You say, I want to move my file from here to here. So you will change to MB. So you will change to MB and you want to rename it because this file is already there, or you want to cut paste. Okay, MB is option is not there. Forceful option is not there. Okay, this is not allowed. Okay, so you can, this one is saying file like this, so you have to change the file name, just give the different name. So I say test2.txt. Now it will allow, but your original location, the file is cut. Hadoop fs -ls testing1 slash. So here is this my data cp.txt is not there. Okay, so it is moved. So cpmb command, same, like it's a same Hadoop to Hadoop file system. You want to copy paste it. Okay. And attribute command is there. Suppose you want to add some attribute, right? Like I want to set some attribute, like I want to identify some metadata. So there is a set f attribute, file attribute you can set, or get f attribute. So you can add the attribute or get the attribute of a file by using the set f attribute or set get f attribute command. Okay, so this one is for setting or getting the attribute. You can create a snapshot, or so many commands are there, like a snapshot, right? You want to create a snapshot, rename the snapshot. Okay, so those snapshot related command are there. Expunge command, find command. This is very important command. Like I want to searching things I want to do. So I want to search any file with the name or regular expression, right? Or some wildcard character, right? So those things I can do, create a snapshot, delete a snapshot there. And I can find the file. Generally in the Unix file system, we can use the find name, right? So Hadoop fs -find -name. Okay, I say my file is, I created a file test2.txt. Suppose this file I want to find the location. Okay, test2.txt. And I'm giving a place like root directory where I want to find this file. So I say I want to find in the testing1 directory. I think this will come first, right? Actually, directory location comes here. Testing. See, it is found. So I don't have any the whole path, right? I don't have, but I got it here, right? This test2 is in the testing1, testing2, and test2.txt. This file is present, right? So I got it, the file. Okay, so this is a find command. And tail command, test command is to check your file is a directory or it is a file type. Okay, there are the various options are there. So if you want to see, one help command is there also. Hadoop have fs -help and particular command you give. So it will tell you all the options, right? It is telling you what is this D option, what is the E option and F option, right? So this is a test command is to check whether it's a file is a directory or it's a what type of file it is. Okay, so these are the different types of options are there. Okay, you want to test whether it's a file or directory. And stat command I already told, attribute, get attribute, rm and rmdir, these two are related to removing the file or directory. Okay, okay, mb command, put command, copy command, head command, get merge command. Okay, and ACL is for the like access control list. You want to set the permissions, like generally you do the ch group, ch mode, right? Ch mode and ch group, ch option. So you can do set ACL. Okay, file level permission you want to set, you can use the set and get file ACL. Okay, so this command you can use. Expunge command, du command and dus command to check the files and directories size, right? So du and then give the path of any file testing. So this root label directory I giving. So it is telling me this is the one empty file is there and one this is the directory. And this directory, further I want to see testing 2. So that information I will get it only for this directory. So this directory has, so wherever the directory comes, it will show 0, but you have to do again. But suppose you give DUS, right? If you give here DUS, so what is the difference? Just check. It is giving only one directory, like testing 1, the whole size is telling, right? It is not telling about all the nested label, right? It is telling all the nested label, right? So DU and DUS. So these two commands, you can check the.
Arvind, I have one
size.
doubt here.
Mm.
When we are giving the get ACL, and what is the difference between get ACL and chmod command? We are giving that permission. We can change the permission, right? Read, write, execution permission. What is the difference between get ACL and
Get
chmod?
ACL or set ACL, like we have to, if you want to set the complete access control list, right? I want to set it. Okay, so I have to use some set ACL command is there. Okay, like you can chmod will be setting only the permission only, but here on a group everything you can do the access control list. Okay. Okay, first any particular, whatever the permission is set, you can check first what is that permission. Okay, we check get FACL, we do. Okay, what is the command?
-get ACL command.
Look F. System got it. Okay. Get FACL, right? Okay, I've checked just for this directory, what it comes. This is a default is coming. I haven't done, right? Whatever is there, it is coming, right? So you can see here, everything is coming, group, honor, and your chmod, everything is coming in a one single command, right?
Yes.
Right. And,
yes.
If you do chgroup, chmod, these are the 3 different commands. So either you can set the ACL by all together in a one single command, or you can do individual command. Okay. So this is the ACL. Okay. I think almost these are the basic command, but the mostly use the put command, copy command, get command. Okay. mkdir, ls command. Okay. So these are the commands generally we use. rm command. Okay.
There is a -set ACL.
Now this command you can use through the Java API also. Suppose this is a command line way. Okay, but command line, what is the drawback? Like suppose you want to do put command for the 100 directory, you want to create a mkdir for 100 directory. So will you create a 1 by 1 100 directories like test
No,
one,
it's
test
not
two,
possible.
right? So in the real way, right, you will be using Hadoop Java API. So Hadoop Java API, what you will do, you will write a Java class, and this Java class will be accessing your Hadoop file system, and using the loop, it will create a directory. So command will be the same, mkdir, but that will be your Java method. That will be a Java API method that will call internally this terminal command only. In the backend, it is creating 1 by 1, but it is internally doing in the loop. And then it will create your directory. Suppose you want to copy the content into 5 different directories. So you can copy the data, rename everything you can, whatever you can do here, command line, same thing you can do through programmatic way. That is your Java API. Okay. So I will tell the Java project, because we have to create a Java project in the IntelliJ, and then we can do that. Okay. So it's a very simple code. Just you should know what is the Java API you have to use. Java HDFS API to create file in HDFS. You can create a file, you can copy file, anything you can do. So we have to write some Java program and we have to access Hadoop file system. So this is the API, Hadoop FS file system. So first I will create a configuration object, and this configuration object I will pass into the file system. So these are all Hadoop API and path API. And I'm checking first the file is present or not. If file system exists, this particular file path is exists, then I will delete. And then I'm using a create command to create. Okay, so this is the for creating a file. Okay, suppose you want to copy or rename file. Okay, copy file. Like whatever we are using the local file system one, right? So I want to copy file or move file. So this all programs are there. So Java API is a automation, right? It's a programmatic way, right? So there are the two ways. One is command line that you are doing manually, but generally if you don't have the access of this HDFS, right? So what is the way? Another third way is there, curl API. Curl command is a REST command, and those command you can run and create a file or directory. You can do some remote HDFS. If you are not using the remote HDFS, suppose this HDFS in my local, so I can use it using the direct Hadoop command. But suppose I don't have access of Hadoop file system, then in that case, I will go for this curl API. I will show that. So this is like copy the file. So but every time you have to do this, like some program you have to do configuration, then file systems. This is the Hadoop file system. And then some utility is there like copy, and then you are giving the source path and target path. Okay. So you are giving your local path, you are reading the file, and then you are writing the file to the Hadoop file system. Okay. So around 5-6 programs are there, like copying, renaming file, deleting file. Okay. So those are the different programs are there. Okay. I will give the complete this Maven project. Okay. So that Maven project. Okay. So another one is a REST curl command. REST HDFS Java. This one, Wave HDFS REST API. So Wave HDFS REST API, this is for the remote Hadoop file system. I can access any file system, Hadoop file system remotely by their IP. So I want to create a file, I want to append a file, open or read a file, and create a directory. Suppose I want to create a directory, I will run this curl command. So curl -i x HTTP, this I will be giving host, port, path, and operation is a mkdir. So if I give this, it will create a directory. Okay. So this particular path is nothing but my path. Okay. Okay. So if I want to run on my terminal, but I have to change this all parameters. So curl -i host I am giving right now my local host, but in the realistic way, if you don't have in the local host, you can give the IP. Okay, here is 9,000, and here we have to give the path, my root folder path, testing1, and operation is a mkdir. Okay, I need to install the curl because curl by default doesn't come with the Ubuntu.
And you need to remove that hyphen backward slash also after 9,000.
Okay, yeah. So this is called Wave HDFS REST API. Okay, we'll see the example with this root path and there is a D John one is there.
We use same commands, right? When we are using AWS services like EMR. Arvind?
EMR? Yeah.
When we are using EMR clusters also, we can use same commands, right? Whatever we are executing here.
EMR cluster, but where we are using in EMR REST API?
The big data clusters when we are using this Hadoop, right?
Okay, remote. See, this is nothing related Hadoop. It's just it's a curl command. It's a general command, right? Okay. Only thing is here you are giving a remote IP, and actually this web HDFS has been exposed by the Hadoop framework. That's the reason you are able to do the call to the Hadoop. If they have not provided this REST interface, then you can't connect, right? So they have provided for the people who are trying for the remote, right? Remote access. Okay. So I'm just showing the example for my local, but if your Hadoop is remote and you have the permission, if you are the valid user, then you can do that. Okay. So here, okay, I think I should try. See, now the response is coming. So now I can use my directory. Okay, so suppose I say here, so after this I gave okay, this is done. Now I check Hadoop fs minus ls slash testing one slash. Actually, this is the initial path you have to give. Okay, this path, whatever the path is there, that you have to give the initial path, like web HDFS, because they have exposed the REST service on this particular path. After that, you have to give your path. Okay, so test one, test three, testing one, we will check. But here it is not created. Testing one, test three. Something is here. This is not giving error. I think this time it came Boolean true. See, yeah. So actually last time it is not returning the Boolean true. Okay. Okay, it is coming. Okay, Boolean true. Okay, but this time is the command is correct. So this path you have to use when you are using, you have to use web HDFS v1. Okay, so this one you do. Okay, So this is the correct path. This web HDFS v1. This is the correct path. Okay, so this way you can do all these activities you can do, right? You can create a file, you can do, okay, rename a file, okay, you can read a file. So these all the curl commands are there, okay, or rename the file. So renaming a directory or file, so you have to give old name or new name, okay. So you have to provide the destination. So whatever you want to change, so you will give the directory path and then you want to whatever the new one, okay. So this one, delete a directory. So you want to delete a directory, so you can use delete method. So just you find what is the appropriate method is there. Suppose you want to list something, get method will be there. Suppose you want to do some manipulation, right? You want to create a directory, copy the file, the put will be there. And otherwise, like if you are deleting, the delete one is there. Okay, so this is the curl command. Okay. Now I'm telling about this Sqoop installation. Okay, so this is Hadoop one we have done. Okay, any questions so far in that?
Yeah, one question. So this web HDFS UI that will be exposed by default, or we need to do any configuration to expose this web HDFS?
It is a by default. Just you use this curl command. You can use any terminal. Just you need to install the curl, but just you use this one and just change your. Here is a 9870 we use. So this one, and then you have to give whatever path you want to give. You this one. This is the correct one. Yeah, this one. So just use curl command, but you specify your method and what is command. Okay, and then what is operation. Operation is important here. What you want to do, this curl command will identify this operation, mkdir, or like it's a rename. What is the operation? Okay, so complete list you can see here in the documentation. So documentation has the complete list of the REST API. Okay.
Okay.
When these are remotely we can do the operation or not?
Operation HDFS, yeah, remote operation. Okay, this command you have to modify. Okay, so next, first I do Sqoop and then I will have to cover the MapReduce also. Okay, because we have the less time. So I do Sqoop installation and just then do the some Sqoop import command. Okay, or I go first the MapReduce, because MapReduce I have to explain the program and the architecture, because MapReduce is a Java one. Okay, so here. Okay, so in the MapReduce, basically it's a two functions. So I just explain first in the MapReduce. Okay. Nobody is using MapReduce nowadays, but it is important to understand the concept of mapper and reducer function. So MapReduce has a two function. One is a map and another one is a reducer. Okay. So map means it is splitting the data across the machines, and reduce is like aggregation. So it is kind of thing you can think, right? You are first splitting the processing into various multiple machines. And finally, when you are aggregating the result, then you are combining the result as a reduce. Okay, but there one more phase comes in between, that is like map and reduce part we write, but that phase is done by the MapReduce. So map phase is there, then shuffle and sort, and then after it comes reduce. So shuffle and sort is basically aggregating, like combining the result and giving to the reducer. So here you can see map output is coming to the shuffle and sort output is coming as an input to the reduce. Okay, so just take an example, like I have
We take
a
short break, maybe.
Okay, already is the 45 minute left, right? Okay, 5 minutes we do break.
Yeah.
5 minutes. Okay.
Thank you.
Meanwhile, I just keep it installation, whoever is there, so they can see. Okay, so we go to the Sqoop download. You have to download the binary. So this version is good for the Hadoop 3.x or 2.x. Okay, they mentioned it 2.6, but this is good for 3.x and 2.x. Okay, it is already downloaded. So here I go to the software, this download folder, unzip it. Okay, once after this, I will rename it. I will remove this part. I will not keep it a big name. It's simple. I will keep it Sqoop 1.4.7. Okay, this is my binary. Okay, so all the bin conf, everything is there. I copy this folder, go to software, paste it here. Okay, and now second thing I have to do, the Sqoop home and bin path I have to set. Okay, so I mentioned in my document. When I go here, like Sqoop home and Sqoop bin path. So I will copy this to and open the bash RC. No, RC and go to at the end of the screen. Here I will set it this. And you need to modify your name. Okay, you remember it. And then Control X, Shift Y, enter, and source command to apply the changes. Okay, once this done, now your Sqoop import command, you can check the version, Sqoop-version. It's very easy installation, just you are setting the path. But two more things we have to do. One is MySQL, because we want to connect to MySQL, so I have to download this MySQL connector jar. Okay, so this MySQL connector jar I can find on this location. This is the Maven repo. I can this MySQL connector jar is downloaded. I have to copy this jar into lib folder. I have to copy into lib folder of Sqoop home. So I go to software Sqoop, and here in the lib folder I will copy. So another one jar also I need, common lang jar. Okay, because later it will give the issue, so I can download. I have already given the path. So here is this is also Maven repo. So common lang 2.6. If you have already installed Hive, you can take it from the Hive lib. But if you have not installed Hive, so you can directly copy from, you can directly download from the Maven repo or any website you can download. So paste this. And this here the jar. Click on this jar, and jar is downloaded. This jar you copy. You have to copy in the Sqoop lib. Okay, so this is copied, but still we need a source, right? We don't have the MySQL installed. Okay, so I need to follow the MySQL installation, and then I can start my Sqoop import. Okay. Well, so you can follow this DigitalOcean link, and it's very easy, MySQL installation. Just you have to download. So first it is saying sudo apt update, and then install the MySQL server. Okay. So I'm copying this command. Next is sudo apt install MySQL server. If you have set up everything, you can do practice. If you don't have setup, you can't do any practice. So setup is must. Without setup, you cannot proceed any practical. You cannot proceed. So setup is important, and then you can do all these Hadoop component, Spark, everything you can do locally, and you can practice.
Hi, Arvind. This is Sharath. Sorry, I joined
Hmm.
late, but I have a question. You said
Hmm.
Java, we can use Java API for accessing web Hadoop. Can we use Java to integrate with Java applications to integrate with HDFS and use the data stored, or what is the
For any purpose we can use. See, this Hadoop is written in Java only, okay, and it's a native, okay. So if you write any Java application, but you need to access the file system first, Hadoop file system. So if your Hadoop file system locally, so you can give the local path. If you see the configuration things I'm defining there, I'm setting the some configuration path, right? I'm setting. So my Hadoop file system locally, I'm using local host :9000, right? If your Hadoop file system remotely, that also you can access through programmatic way from your machine, you can access, but you need to give the IP there. So then once you have the access of your file system, then you can play around anything. Like same like if you are using Java API for local file system, you use file IO. IO is there, right? So file IO or input output stream you use, right? You create a file object and then you use input stream, output stream, right? Same input stream, output stream they are using, but they are using for file system. They have given the Hadoop file system name file system FSD input stream, output stream. So those APIs they have given the wrapper. Okay, but everything is written in Java, right? So you can directly use their mkdir method or copy, rename. So you can directly call anything. Yeah. Even Python also is supporting, right? Python also you can use the API, but we need to find, right, SDK. Generally, any cloud provider, if you know AWS, GCP, they are providing different way to access their cloud, right? So one way is like command line is there. One way is user interface is there, console, right? And one way is there some SDK API is there, right? Okay, or some Lambda, Python. So there are the different ways are there, right? So how many APIs they are supporting, right? Either Java, Python, Perl, Ruby, PHP. So how many languages they are supporting? Yeah. The advantage of using the SDK API is like you can do automation, like programmatic way, you can do customization. Like you can write your own customization logic, you can write like how many files I want to copy, remove, delete, right? I can do. But for one particular file or directory you want to do, so you can do either with a command, no need to go for API.
Yeah, one use case that what I wanted to do is like if there is any data in HDFS using Java programming, we can write jobs where they can be dumped into MongoDB or MySQL right, Arvind, on daily basis. Using Java.
Mongo, but this is not related to Hadoop, right? Mongo and this one, right? Okay, you want to read from the Hadoop file system. Okay, so you have to use HDFS API and then read the content of file and write to the, suppose JSON file you are reading using the HDFS Java API and you want to write in the Mongo. So then
Or
you have to
MySQL.
use Mongo API. Mongo Java API, you have to use like Mongo client, and then you have to use the like that way you have to do. If you are using Cassandra, so Cassandra also having the Java API, Python API. Okay. So this is like a to and fro, anything you can do, right? Anywhere you can take it and anywhere you can write it, right? Okay.
Yeah. Yeah.
Okay, this MySQL is, so I can start the service. Next thing is I have to go sudo MySQL. I have to enter because my password is not set. Okay, so I have to go to MySQL, and here I have to give the password. So here, this is the command alter user. So user is a table, right? And there is a root user. I want to add the password is the password. Okay, you can change this part first. This password you can give anything. Okay, so I'm keeping very easy one like password. Okay, so I'm just doing this command. Then I will exit it, and then I will test it by using MySQL. I want to start the MySQL -u root -p. After that, it will ask you the password. You give the password, and then you are entered. Okay, now I will create a database. So same thing, whatever you do in the MySQL, create database. I just giving a name of the database is Sqoop. I will do the Sqoop, and then create table. ID, integer, name, varchar, 50, age, integer, salary, double, insert, EMP values. So some data, dummy data I'm putting. Okay, so suppose this is my data. Now I want to, now everything is ready. My MySQL is ready and my Hadoop file system is ready. So now I want this data as a file in my Hadoop file system. So I need to use Sqoop import command on my terminal. Okay, so here I have to use, or anywhere you can use, because we have already set the, so Sqoop import command we will use. Sqoop import. Okay, so we have to write a complete syntax of the Sqoop import. Okay, I just. Suppose this is my Sqoop import command. So I have done the data preparation. After that, like Sqoop import connect JDBC MySQL localhost 3306, and this is my database. The database name I given is Sqoop, and username password. So this is the same password and same username, and this is the table, and this is the target dir. This target dir should be the Hadoop directory. So this directory, whatever directory I'm giving this target, this should be a new directory. Okay, so I will create a one directory in my Hadoop file system, Hadoop FS minus mkdir. Okay, Sqoop directory. So this directory I created. Now inside this directory, I will create for the new ingestion, I will create a new directory. In this Sqoop 11, our file will be copied. Okay. Right now, this command will not copy here. Actually, bidirectional, it can copy paste it if you have enabled here in the virtual box, but somehow it is not working. So here in the root, if you go advanced, here the bidirectional is set. So this bidirectional means like you can copy something in Windows to the in the virtual box, you can copy paste, but it's not working. Okay, so this command I will open. So if you don't have, then you can use this way. You can try. Okay, so this command on the dollar shell I have to run. And this virtual machine have the 50 GB RAM. Okay, this here it is. Those are the old terminal, then it is not picking up. Okay, so if you see here, so it is starting the map reduce job, but in this Sqoop job is a mapper job. There is no reducer because it is just fetching the data. So when you are fetching the data, you are not doing any manipulation. So it is only mapper job. Okay, so there is no reducer. So if you see, it will start the map 0, reduce 0, then map 100% and reduce 100%. Reduce is a 0%. Like it will not be any reducer. Okay, so when we see after copying, right, once this Sqoop import is done, it will create a file, one part m file, part m hyphen 0005. It will create. So this job you can see in the local host in my cluster. So this job I can see in my cluster. This Sqoop job is created. So if I go to my cluster location here, if I see my cluster, if I refresh here, see this is the Sqoop job. And this Sqoop job, I can see the log. I can see the log here. So you can see the log. This is a map reduce type, but this is a Sqoop job. This is the log. If you click on this. So you can see the status of the job here. And command line also where we are running it. So it is still is running. So here is the log. See, Sqoop job is completed. So now I want to check my Hadoop directory, Hadoop FS -ls / Sqoop. I given Sqoop 1 or Sqoop. Sqoop I given. Okay, and there it has created Sqoop 11. And if I check it is directory / Sqoop 11. So here you will see one part M file is created. Now I want to see the content of this file. You can see Sqoop 11 part M 5 zeros. So you can see the whatever the content is a comma separated is a file. Okay, so it's a one file is created as a CSV file. The data is coming as a CSV. So this is a basic Sqoop import command where we are using all the parameters, right? For the connection parameters and those things. Okay, so what other things we can do in the Sqoop import? I will explain it and you can try those commands, okay? Because I cannot run all the command because it will take more time. So if you want to set some more number of output file, so you can use the -m parameter, -m for the number of mappers, like you want to run how many number of files parallelly. So it is used by the -m parameter. But in this case, you have to use -- split by column as well. So this -- split column is the ID column where your number of records will be distributed equal number of size of the file based on this -m parameter. So suppose I have a two records and I'm using -m2. So one record will go to the 115. Okay. So that is the use of the -m number of parameter. Okay. Another option is suppose I want to delete my target. So you know, right, every time you have to create a directory. Like if I run this Sqoop import command, it will give me the error. What error will come? It will give me the error your directory is already exist, because the same directory you are trying to copy the file, import the file. Okay, then it will give you the error. So this error is it's already exists. Output directory is already exists. So you want to avoid that. So there is an option -- delete target area. If you add this parameter, if you did add this parameter in your command, so it will not give any error. So you can add it here before target dir. So it will delete the directory. It will delete the directory and then create a new directory with the same name. So now this time it will not give the error. Okay, so you can avoid this error by using the delete target dir option. And another option you can give field terminated by comma, or comma is a by default delimited character. But suppose you want to get the file should be dollar symbol or any other symbol, right? So you can give this parameter field terminated by. So if you want to give this, you can give. So your output data will be separated by the dollar. So this is a new job is created with this application ID 002. Okay. So every time when you are running a job in the your resource manager cluster, you will get every time a new job is created. Okay. So there is a yarn command is there, yarn log command. You can see the log of your, so you can use yarn logs -- application ID, and then you can give the application ID value. So what is application ID is generated here? This one, application this. So this value you give, it will show the log on the command line. So you can give it this value here, but you have to remove this slash. And then it will show you the complete log, whatever log you are. Okay, the file is not exist. Even the correct one, 002. Okay, might be it is removed. So this command is used to see the your log of any application ID, your job log. Okay, you can see. If you want to run this Sqoop import command with the this field terminated by, okay, so you simply run the Sqoop job. Okay, suppose you want to give in your import Sqoop import command a specific column only. You don't want all the fields. So you can add table, and after that you can add -- column. So only those specific column will come in your file. Okay, all columns will not come. And another way is there, like suppose I want to write a free form query. Free form query is like, suppose I want to get a specific data from my table. I don't want all the data. Some condition is there, like, okay, I want to get only ID1 data. Okay, right now only one record, but I'm saying that suppose I want to fetch some condition based data. Okay, so you have to use -- query parameter, and there you have to select star from table. But here you have to give one extra, this $condition parameter. It is mandatory. So once you give this $condition parameter, so there are condition, and another one you can give your own condition. If you don't give any other condition, so it will bring all the data. But if you want to say, like, you want to get the record which is greater than 1, so it will fetch only ID is greater than 1. Okay, so you can run this query. Right now this will not bring any data for our case because I have only ID1. So this one is retrieving only one record. Okay, so if I'm doing this, so I add one more record in the MySQL, so I can see. So I will do the insert command. We have to run one more time. Maybe it has already fetched. Okay. Okay, it has fetched. So Hadoop API minus ls slash, what is my target dir? Sqoop slash Sqoop. So here is the one part file is created. Part name -000. Okay. See, your second record data is coming. Actually, by the time we inserted record, it has taken after that. The $2 by $$ is coming. Okay, so whatever we have given the field terminated by, it is coming. And this is a -- query. And in the Sqoop is having import all table option. Import all table option is importing all the tables. Like generally Sqoop import command only for one table at a time because we specify the table, right? But here I'm doing a Sqoop import all table and I'm giving the database. I'm not giving any particular table here. So I'm giving Sqoop import all table. Sqoop list databases. I want to see how many databases are there, how many tables are there. Okay, so I can copy this. I'm not giving any particular database name here. I'm just giving simply list databases, and I'm giving localhost colon 3306. So it will give me the list of databases. So these are the list of databases. If I want to get the list of tables, so there is a command. These are informative command. It is not doing anything. It is just giving the information about your database and database table. Okay, so actually here I have to change this Sqoop to Sqoop. My database name is a Sqoop. So in the Sqoop database, how many tables are there? So I have to give this command. Okay, so this is only one database table, only one table EMP. Okay, so import all table I'm not doing. You can try 2-3 tables you create. But suppose you want to exclude some table. Suppose you say you have 10 tables, but you don't want to import one table. Okay, so you can give that table in the exclude table option. Okay, so your table will be exclude and remaining table will be imported. Okay, so this is the option you have to give, exclude table with import all table. So import all table is the option when you want to import all the table, but you want to exclude, you have to give the exclude table option. Okay, so this is the command. Suppose you have an incremental load of the data. Today you have 100 record and tomorrow you got 20 more record. So if you do simple Sqoop import command, it will bring every time the whole data. But I don't want to bring whole data. I want to bring only new 20 record. So how to do that process? So that is called incremental load of the data. So we have to use Sqoop incremental load. Okay, so I'm showing you. Sqoop is having just command. You can use those command and then you can use it. Okay. So this is Sqoop 2 document. I have a first is incremental load. So suppose 100 records are there for this particular date and 20 record came the next day, but it will be doing always 120 record. But I want only incremental data. So I have to use this command, Sqoop import ---- connect. This is same thing, username, password, and the table. So my table is here, EMP. I can change here. And this is my any directory. I'm giving incremental append, and the check column is I'm giving ID column. So which column I want to check this incremental. Okay, so first time I'm running this query. First time I'm running the query because it will return me the last value. So right now my record is only 1. So what will be the last value? My last value will come 1. When I run this Sqoop import, my last value will come 1. Okay. And this last value I have to remember manually. Okay, I will tell the another way is there, Sqoop job. So you create a Sqoop job for your Sqoop import command, then you don't need to remember this last value. Because second time when you run this Sqoop import command, you have to give this last value. If you are not using the Sqoop job, if you are using simple Sqoop incremental command. So this Sqoop incremental command, you have to give incremental append mode, incremental append. And the next time when you are running the command, append mode, second time you are running this command, so you have to give your last value. So what will be my last value here? 1, because my table has only 1 record. Okay, here I change EMP. Oh, two records are there. Okay, so okay, here I will get 2. because I inserted one more record, right? So I will give my last value 2. And then I will add some more record. I will add the third record. Okay. So once this Sqoop import is completed, okay, can you check here? Last value is coming 2 and check column ID and incremental append. Now I want to verify it. Hadoop FS minus ls. Some INCR column I given, folder I given. So here is a one part M file is created. Part -m. And here you can do cat command. So you can see 2 records are coming. Okay. Now I add one more record in my MySQL. Just I run my insert query one more time. 3 G. Okay, so one more record is added. So now I will run my incremental load. So this incremental load, I have changed here the last value 2. Okay. So this is the problem in the Sqoop incremental load here. Like I have to remember the last value. I will run this job again. So it will not delete any directory because it is creating incremental file. So you will see in the same directory, one more file will create with the new data, right? Only one more record came, right? One new record, the third one. So only one more file, one new file will be created in the same folder. So here is no need of delete directory. Okay. So this thing we can overcome in Sqoop job. So Sqoop job we define as a job as a Sqoop import command, and that job you can run multiple time, and Sqoop job has the option to retain the metadata about the job. So now that your last value has become 3. So this is the cycle. So now you insert any more record in your table, and then you have to give in your Sqoop incremental load command. You have to give the here last value 3, and then you can load the latest data. Okay, now we see another file is created in the same one, part M001. And that one has only one record. Can you see here? 3G12. So this is the latest record, right? So this is a Sqoop incremental without using the job. Okay, so now next thing I'm going to show you how to create a Sqoop job. So Sqoop job is a one way, like you will create a first Sqoop job -- create and give the job name. So I'm giving us some XYZ job. Okay, so I'm just giving a job name. My job 1, and now I'm giving import. So here you remember Sqoop job, and this import should have space. Okay, after that your parameter will remain same, whatever parameter you given above, right? Driver you are not giving, but yeah, you are giving the connect, username, password, table, target dir. So this direct target dir, I'm creating a new directory. Okay, so I say this incremental one. Okay, and I say incremental append, check column ID, but I don't need to give the last value here because it will automatically maintain your last. First, I'm going to create a job. I tell my Sqoop job which is my table, and what is this is an incremental append. So it will be incremental append only, but it will be a through job. Okay, so when I run this command, it will not do any Sqoop import. It will just create a job. It will just create a job. Okay, some JSON jar we need to copy from the any new installation we do, so we have to This jar is not by default coming with the Sqoop installation directory. That is the reason we need it. So we have to copy in the Sqoop.
How do you
Lip
decide
folder.
which one to copy? How do you decide which one to take? You just, yeah.
This is a standard jar, right? This is a Google JSON jar. Okay, org JSON. Some third parties are there, but we can use this one, a standard one. Okay. Sqoop. Lip. At least we need this class. Okay, because my job is created. So first of all, it is giving the error because even this error is coming, but job is created. Okay. So there is no provision to change the job. You have to delete the job or you create a new job. Okay, you cannot modify. So now this time we didn't get any error, right? So it means like our job. So I can see the list of jobs, Sqoop job minus list command is there. So it will tell you how many jobs are there. If you want to see the metadata of the job, you can see minus show and then say the job name, my job 2. Okay. So it will show you the metadata, but it will ask you second time password. Okay. It is a secure one. So here, if you see, this is all metadata. So here the last value will automatically come. Okay. When you check, when you run the first time Sqoop incremental load, it will automatically modify your last value. What is the last value is, right now your Sqoop import is not started, right? Now I will do the one command, Sqoop job minus excc, and then you give the job name, job 2. Okay. Now this is the actual import. This thing. What is the job name? My job 2. Okay. So I'm giving a wrong name. My job 2. My job 2. So this is doing actual Sqoop import. So this is providing the reusability. What is that? Okay. So now if you are doing something mistake in your Sqoop import command, now you cannot modify this Sqoop job. You have to create a new Sqoop job, or you can delete this and create a new. So you have to create a new Sqoop job. Okay. So I'm creating again my Sqoop job. I change here the database name. This parameter we should make sure first, right, before creating a job, because you cannot change the job. So you have to create a new job. So I'm creating a new job. Okay. Now I can execute this job, my job 3. It asks password one more time. Okay. So this is incremental load is doing, right? Because we are using minus incremental append. So two types of mode are there, incremental append or incremental modify timestamp. So two mode. So modify timestamp mode is basically updating your existing record, and incremental append means like you want to add a new record, like you want to create new record, only new record, which is latest one. Okay, so now this job is done, right? So now I just check my directory. What is the place where incremental one folder? Okay, so Hadoop API minus ls slash Sqoop one slash Sqoop incr1. This is my directory for the incremental by using a Sqoop job. Now I see this file, part M. So file naming convention is part M 00. If multiple files will be there, so it will be 001, 002 like that. So Hadoop API minus get. So this is the first time. This is the first time, right? Because we have run through Sqoop job. So first time it will bring all the data, right? So now whatever records are there in the table, it is the first time. So it came all the one. Okay. Now I show you the metadata. Okay. Sqoop job minus show my job 3. My job 3. So you see. Okay. So here in this metadata, you will see the last value. The last value is 3. So now any new record you are adding in your MySQL, that will become your next new record. Okay. So now I will be creating a new record. One more record I'm adding, incremental. I'm adding incremental. So 4. Okay. 4 and P. Okay. Now I'm running up. Now I don't need to write any Sqoop import. Just run this job. Execute. Just run the job. That's it. Okay. So that is the reuse of the job. Sqoop job is provide the reusability, right? For incremental load, it is giving a benefit, like it is, we don't need to remember the last value. But the main advantage of the job is reusability. Like you don't need to write Sqoop import again. Once you define your Sqoop job, it will do automatically. So this time only one record came, retrieve one record, and now you check the directory. So now the new file will be there, 001. So 001 only one, right? So if you do ls, so you have this folder 2 files. 2 files are there. One is 3 records and one is a 1 record. Okay. So one is 3 record, one is a 1 record. So this is the latest file came. Okay. Now metadata we check. So Sqoop job minus show my job 3. Now you see here the last value will become 4. So you don't need to remember, right? So this is the advantage of Sqoop job. Okay, let's see that what is the pending one in this. Otherwise, I will complete tomorrow. Sqoop job. This is all I have already told. List and all these commands are there. Okay. You can use the limit 3 on this one. Okay. Sqoop has some other commands are there. Sqoop code gen, like you want to generate the Java code and you want to do your own modification. So code gen is there. And next thing is only one Hive. So when I will complete Hive, then I can show the Sqoop import for the Hive table. Okay. So only MapReduce part is left. So I will do tomorrow MapReduce first, but you install the IntelliJ. So you go to, I will provide the IntelliJ and this complete installation document. There I will mention the IntelliJ is simple. Just you go to the download IntelliJ. Like you need a download IntelliJ. So community version you can download. Download the community version of IntelliJ. So I will show you the MapReduce job and concept of MapReduce, right? And the MapReduce Java program, and then I will show the Hive installation first. So here you go to the download this community IDs. So what you need to do, you have to download first, then you extract this IntelliJ and go to your software folder and copy here this IntelliJ folder and go to bin directory, right click here, open terminal and idea.sh. So here you type /idea.sh like this command, and then your IntelliJ will start. Mine is already started. So it is running already on the terminal. Okay. So it is already running on the terminal. So you will see your UI will start like this. Okay. And there you can import the project. So somebody who has the Eclipse, they can use Eclipse as well. Okay. So this Maven project. So if somebody doesn't know how to create a Maven project, I will show that Maven project, how to create a Maven project from the scratch, and then we can copy paste this file and then run the word count program. And the same program we will run here in IntelliJ, as well as I will run it in the run on the Hadoop cluster, like using the Hadoop jar command. Okay, so both the ways we will see like how to run a simple MapReduce program. So we have 3 classes. One is a driver class. This is a driver class, and one is a mapper class, and third one is a reducer class. So mapper class and reducer class. Okay. Okay. Anyone has any question? I'll share this video recording as well as the drive, like the source code and this installation things. Everything is there.
And can you
I
please
think
share
same
me
drive.
the document also, Arvind?
Which document? Oh, the
The
PDF
text.
one. This
Text.
one.
Yeah.
This one
Not
also
that,
I'll share.
and whatever your commands you are executing the commands, right?
Yeah. That I will share because that is all command. Okay, this command.
This one. Yeah.
Okay. Yeah. Thanks everyone who are attending.
Thanks.
Thank you.
Bye. Good night.
Thank you, Arvind. Nice session. Yeah.
Thank you.
Thank
Bye.
you.